So in the last video, we discussed and we defined software testing, right? Defined what software testing is and what's its use. And in this video, we're going to discuss principles of testing, right? Principles of testing. We're going to be explaining the principles of testing. There's 7 principles of testing, right? I'm going to be explaining all these principles to you. Testing is a crucial element of software development, right? It can also be a complex activity to structure correctly, so in a way that supports maximum efficiency. So it's helpful to review the process and guidelines to ensure you are following best practice, right? Testing. Okay. So what are the 7 fundamental principles of testing, right? Number 1, testing shows the presence of defects, not their absence, right? Testing is always done to show the presence of defects in a software application. Right? We use testing to discover issues so that they can be fixed before they're deployed to live environments. A live environment means like environment that is accessible to everybody, the users. Right? This enables us to have confidence that the systems are working. Right? But testing is not used to confirm that the software is completely devoid of issues. Right? It's just used to identify and greatly reduce the number of undiscovered defects hiding in software. Right? Although it's not 100% foolproof, but it helps to mitigate this risk to a large extent. So, number 2, exhaustive testing is impossible. It's not possible to find all the defects in a software product, right? So, exhaustive testing is impossible. That's the second principle of testing. As much as we would like to believe it's true, it's absolutely impossible to test everything. All combinations, inputs, preconditions. You could also argue that attempting to do so is not an efficient use of time or budget. However, one of the skills of testers is assessing risk and planning your test around these. Then you can cover vast areas, making sure that you're testing the most important functions, right? Careful planning and assessment, the test coverage can remain good and excellent and enable necessary confidence in the software, of course, without requiring that you test every single line of code. So it's impossible to test everything. So let's go to the third principle of testing. Early testing saves time and money. Talked about this in the previous videos of how early testing can save you time and money. It's a fundamentally important part of the SDLC, software development lifecycle. This could even mean testing requirements before coding has started, right? Amending an issue at the requirement stage is a lot easier than amending it when the code has been written or when it has been deployed to a live environment. So while you still have the requirements, you still spec out the requirements and no code has been written, it's way easier to amend requirements at that stage. So early testing is also a fundamental agile principle, which sees testing as an activity throughout rather than a phase, right? In which traditional waterfall approach will be at the end, because it enables quick and timely continuous feedback loops, right? So when a team encounters all those impediments, early feedback is one of the best ways to overcome these impediments. Test continuously throughout the life cycle and ensure that the developer gets quick feedback so he can remedy bugs, situations, and whatever that may be found during testing. So the fourth principle of testing is that defects cluster together. So there's the idea that certain components or modules of software usually contain the most number of issues or are responsible for the most operational failures. Testing therefore should be focused on these areas proportionally and expected and later observed proportionally to the expected and later observed defect density of these areas. Yeah, the Pareto principle 80-20 can be applied to this. So 20% of the software might bring out or might have 80% of the defects, right? So this is particularly the case with large and complex systems, but defect density can vary for a range of reasons, right? Issues are not evenly distributed throughout the whole system and are more complicated. And the more complicated the components or the third-party dependencies are, right, the more likely it is that there will be defects in that software. So if you have more complicated systems, right, lots of integrations to different third-party systems, there's a high possibility that there are a lot more defects in that system. The defects could be from your own system or could be from third-party integrated systems, right? So that is the fourth principle of testing. So the fifth principle of testing is to beware of pesticide paradox. This is based on a theory that if you use pesticide repeatedly on crops, insects will build up immunity, rendering it ineffective. Similarly with testing, like if tests are run continuously, then while they might confirm that the software is working, eventually they will fail to find new issues. To run the same test continuously over time might just confirm that the software is working, but you won't find new issues. So testing needs to be varied from time to time across the software development lifecycle to ensure that new issues are found. Can't keep running the same test over and over again and expect to find new issues. That's the pesticide paradox testing. So let's go to the sixth principle of testing. It states that testing is context dependent. So testing is all about context, right? The methods and types of testing carried out can completely depend on the context of software systems. So for example, an e-commerce website can require different types of testing and approaches, right, than an API application or a database application, right? So what you're testing will affect your approach. It's as simple as that. Can't test a mobile app the same way you test an API. Can't test an API the same way you test a web app. Can't test a web app the same way you test a database app, right? The app you're testing will determine the approach you take towards testing of that system. Right. So let's go to the seventh principle of testing, which says absence of error is a fallacy. It's a fallacy, right? It's like a fairy tale that there are no errors in your software or in your code. It's a fairy tale. There are always issues, whether discovered or undiscovered. Sometimes you might discover the issues during testing. Sometimes you might discover the issues further down the line in live environments, right? Race conditions can always bring up issues, right? So, and these race conditions, of course, are special. They are special events that happen, right, in a software. It can be due to the deployment environment, due to the kind of programming language used, a variety of conditions, a variety of issues can come up dependent on the technology used and a lot of other conditions. So a lot of these conditions can be unexpected, right? And they might not be thought about by the tester or the QA team, right? As at the time of testing. So absence of errors is a complete fallacy. It's not possible that there are zero errors in a software product. Errors might not just have been identified yet, or they might not show up at the time of testing. But it's entirely possible that errors can show up later on in the software development lifecycle. So these are the 7 principles of testing. And these principles are always true. They're always, they always work. They're always true. And I'll see you in the next video.